Which of the following statements is true about non-probability sampling? There is significant risk that the sample is not representative of the population. That is true. Every member of the population has an equal chance of being selected for the sample. That is not true. Using judgment guarantees that the population subdivisions of interest are represented in the sample. Well, I'll get rid of this word and just say increases the chances. Using judgment increases the chances that population subdivisions. Nothing guarantees that it will happen. So we have to go with A. The best approach for creating a stratified random sample of a population involves drawing an equal number of simple random samples from each subpopulation. And you may read that and you say, well, yeah, that sounds like stratified sampling, and you may be willing to take that. But let's just put a question mark there. It sounds good, but let's just see if another option sounds better. Selecting every kth member, that is systematic sampling. We could just get rid of that because we're looking for stratified. Drawing simple random samples from each subpopulation in sizes proportional to the relative size of each subpopulation. There we go. So A seemed like it was on the right track, but if you keep reading, you'll find that C was better. So let's just be cautious not to take one that we read and say, aha, that's it right there. I'm pressed for time. Let's move on. It wasn't complete. A population has a non-normal distribution with a mean mu and variance sigma squared. The sampling distribution of the sample mean, computed from samples of large size from that population, will have the same distribution as the population distribution. Well, no, the distribution of the sample means will be approximately normal because we have large size. And this is saying that this is non-normal. This will be normal. We can get rid of that. Its mean approximately equal to the population mean. Yes, the mean of this distribution will be approximately equal to the population mean. And that is a result of the central limit theorem. We can accept that. Its variance approximately equal to the population variance? No, the population variance is sigma squared. The variance of this is called a standard error, and it'll be sigma over root n. So we can get rid of that. We're left with B. A sample mean is computed from a population with a variance of 2.45. The sample size is 40. The standard error of the sample mean is closest to. Since we know the population variance, we will use that, 2.45, and it's the square root of that because we're looking for the standard error. It is S over root n. There's our S. What is our n? 40 over root 40. Root 245 over root 40 is 0.024, sorry, not 0.0, is 0.247, 0.247. Compared with bootstrap resampling, jackknife resampling is done with replacement. No, it's not. Remember, if we have a data set, let's say n equals 30, we will drop off the first one and use a data set of 29. Then the second time we'll drop off the second one and use a data set of 29. Then we drop off the third one. We just drop off one at a time. So it's not with replacement. Get rid of that. Usually requires that the number of repetitions is equal to the sample size. Yes, we would only do this 30 times because there are only 30 possible variables that we can eliminate one at a time. Produces dissimilar results for every run. Well, no, it'll produce similar results for every run. It is sampling that has the higher chance of producing dissimilar results for every run. Sorry, not sampling. Bootstrap resampling would do that. So we can get rid of this. B.